So therefore, here we have a diagram and we have to apply circle theorems. So make sure that you have your circle theorems, prepared mentally because you can go into the exam with it. So even before looking at the question, go to analyze the diagram and see if you can pinpoint the theorems therein. So we have a circle and we have a tangent. Once you have a tangent, think of the alternate segment theorem. The way the alternate segment theorem operates, it says that the angle that lies between a tangent and a chord, okay, so the chord here is AC they are talking about, and here the tangent going across here, is equal to the angle subtended by the same chord, meaning that angle up there subtended because AC is a chord, and then from C going up to B now. So that's what they mean by subtended. So you have to go away from AC, coming back now to A. So that angle CBA, which is away from C, which is away from AC, is equal to that angle there. Okay? So it's like interior opposite, I normally call it. So you have an exterior angle here and the interior opposite, okay, towards of that, away from that chord, is equal in size. So if we have a tangent and we have a 56, so there must be a 56 inside there somewhere. So AC is like NK. So when we go inside now, that angle subtended by NK is away from NK right here. So KMN supposed to be 56 also. Okay. Supposed to be 56. Okay. By virtue of this theorem. And there's another 40, there's a 48 degrees inside of this. We have to get the chord that we are talking about, which is KL, and we have to go away from L. And here now, LMK is 48 degrees also. Okay, so KMN is 56 degrees. And LMK is 48 degrees. And right away, cyclic quadrilateral, we can get this angle here, NML, 48 plus 56, because in the cyclic quadrilateral, opposite angles are supplementary. So we can get NML, subtract it from 180, and we can also get this angle right here, LKN. And there's another way to get LKN is by adding 56 and 48 and subtracting it from 180, so which comes to the same, that NKL, okay, is supplementary to LNN, okay. Another theorem that we can take a look at is the radius and the tangent makes a 90 degrees. Here it is. The radius and the tangent makes a 90 degrees. We have a radius, which is OK, and we have a XKY, which is a tangent. So this radius and this tangent makes 90 degrees. And we can make use of this 12 by subtracting, by adding 48 and 12 and subtracting from 90. Then we can get MKL, this angle here. We can get this angle here, MKL. And also, a lot of theorems it appears to be OKL is an isosceles triangle because OK and OL are two radii equal in length. So therefore now, OKL and OLK are equal in size. Isosceles have triangles, have two sides, two angles equal. Okay. So all this we can apply here. And also we can get this angle by adding those two angles, OKL and OLK. Subtract from 180, we can get LOK. We can also get LOK. So having analyzed that, let's go to the question. So the question says, find the value of angle KOL. Give reasons for your work. KOL. Let's find KOL. So basically what we can do now is to add 48 and 12 and subtract it from 90. That will give us 30 degrees. You add 30 to 12, that will give us 42. So OKL is 42, OLK is 42. So you multiply 42 by 2, okay? And then 42 by 2, that will give us 86. And then we subtract 86 from 180 degrees because the three angles in a triangle add up to 180 degrees. And then we are going to get our final answer, which is 96 degrees for KOL. So now we have to find LMN. So therefore now, as we said before, NKX is 56 degrees. And yeah, so NMK is also 56 because alternate, segment. And LMK is 48 because of the same alternate segment theory. So just add 56 and 48, and that will give us 104, and that will give us LMN. Or another way, which is a little bit longer, you add the 56 and the 48, subtract it from 180. So you're going to get NKL, and then you're going to subtract that answer from 180 again, from cyclic quadrilateral, alternate opposite angles are supplementary. You will bring it back to the same 104 degrees. Now here now, we want us to find KLO. KLO. So KLO, as we said, is 42 degrees. It's 30 plus 12 because remember, this is an isosceles triangle. Two angles are equal. And we get this 30 to add to the 12 because this OKY is 90 degrees. So we add 48 and 12 and subtract it from 90 to get MKL. Add it to 12 to get 42, which is OKL, which is the same as OLK. So OLK is 42 degrees by virtue of isosceles triangle. And also radius and tangent makes a 90 degree. So there's another one called MLK. Let's find MLK. Angles in a triangle. Now bear in mind we have already gotten LKM, which is 30 degrees, because we add 48 and 12, subtract from 90. We already get KML, which is 48 degrees. Alternate angles are equal in length. So we have two angles in a triangle and three angles in a triangle add up to 180. So we add 30 and 48 and subtract from 180 degrees. And that will give us MLK. So therefore, MLK is 102 degrees. So also let's find angle KNM. KNM. Now, as we notice now, MNK and KLM are opposite angles in a cyclic quadrilateral, KLMN, and these angles must be supplementary. So you just subtract 102 from 180, and that will give us 78 degrees. And the reasoning is that opposite angles in a cyclic quadrilateral are supplementary.